Root test. Let the summation of an be a series such that an is greater than 0 for all n an element of the natural number. 1. Suppose there exists 0 less than c less than 1 and k is an element of the natural number such that the limit as n tends to infinity of the nth square root of an is less or equal to c, then the series converges. 2. If the limit as n tends to infinity of the nth square root of an is greater or equals to 1, then the series diverges. So that's the definition of the root test. So in the root test, we have a series. Now, after finding the limit of the nth root of that series, if the limit is between 0 and 1, then that series converge. But if the limit is greater than 1, it diverges. Let's take an example. Show by root test that the series, the summation from n equals to 1 to infinity of 2n all over 3n plus 1 raised to power n is convergent. Show that this series is convergent. And we're going to use the root test. From the root test, we work with the summation of an. So the summation of a sequence which gives us a series is equals to the summation of from n equals to 1 to infinity of 2n over 3n plus 1 all raised to the power of n. Hence, an will be equals to 2n over 3n plus 1 all raised to the power of n. So this must be an. Now what will be the next step? Now let's look at the definition. In the definition, we need to find the limit as n tends to infinity of the nth root of an. So let's work with that, which is limit as n tends to infinity of the nth root of an. This will be equals to the limit as n tends to infinity of nth root of bracket 2n over 3n plus 1 close bracket n. So we need to simplify this expression. And this gives us the limit as n tends to infinity. Now, do you observe that this nth root will cancel this n? Of course it will, because if we have the fourth root of 2 raised to power 4, this fourth root will cancel 4. So this nth root will just cancel this n. Of course, to make it easier to solve with. So if the nth root cancel n, we are left with 2n over 3n plus 1. So right now we are at the limit as n tends to infinity of 2n over 3n plus 1. Now while dealing with the limit as n tends to infinity, what we need to do here is to divide all the terms with the highest power of n. The highest power of n here is 1, so it becomes the limit as n tends to infinity of 2n over n all over 3n over n plus 1 over n. Now this gives us the limit as n tends to infinity of 2 n over n cancel n, we're left with 2 all over 3 plus 1 over n. It becomes 2 over 3 plus 1 over infinity. Then this becomes 2 over 3 plus 0. 1 over infinity gives us 0. And this gives us 2 over 3. So the limit is 2 over 3. And 2 over 3 is equals to 0.6667, and this number is less than 1. Now what happens when the limit is less than 1? Let's check the definition. When the limit is less or equals to 1, the limit is between 0 and 1, then the series is said to converge. So hence, since this limit is less than 1, the series converges. Let's have another example. Example 2. Show by root test that the series, which is the summation from n equals to 1 to infinity of 2n squared all over n squared plus 1 raised to power n, is divergent. So we need to show that this series diverges. So the first step, recall that in the root test we make use of this, the series, the sum of this sequence, and the sum of this sequence is equals to the summation of n equals to 1 to infinity of 2n squared over n squared plus 1 or raised to power n. And this implies that an is equals to this expression here. An is equals to 2n squared all over n squared plus 1 all raised to power n. The next step is to find the limit as n tends to infinity of the nth root of an, which will be equals to the limit as n tends to infinity of the nth root of 2n squared all over n squared plus 1 all raised to power n. Obviously, this nth root will cancel this n, so we'll be left with the limit as n tends to infinity of 2n squared all over n squared plus 1. At this point, we need to divide all the terms with the highest power of n, which is n squared. So it gives us the limit as n tends to infinity of 2n squared all over n squared divided by n squared over n squared plus 1 over n squared. If we simplify this, we have the limit as n tends to infinity over 2, so n squared cancel n squared, this n squared cancelled s squared 1 plus 1 over n squared. It becomes 2 all over 1 plus 1 over infinity squared. This gives us 2 all over 1 plus 0, and this is equals to 2 over 1 equals to 2. And since 2 is greater than 1, let's see the condition. In the definition of root test, if the limit is greater or equals to 1, then the series diverges. So hence, the series diverges. If you want to learn more about the root test or any other test that has to do with the test of convergence, you can message me directly on WhatsApp. Meanwhile, subscribe to my channel, like and share this video. I will see you in my next video. Bye.